I'm delighted to be here today. My name is Christine Van Chang. I'm the co-founder of the Space Research Company. We're a team of aerospace engineers and scientists that put experiments into space. Our small satellite makes space research affordable and accessible for everyone. As a grad student, my co-founder and I actually had the privilege of flying 5 different experiments to the International Space Station. We've seen firsthand how this incredible microgravity environment profoundly changes biology. For example, antibiotic production increases 5-fold. Leveraging this information, we can help improve yields here on Earth and reduce costs. Another example, bacteria in space, for some reason, become a lot more virulent and toxic. We can use this information to develop better drugs. In fact, these diseases listed here already have drugs on the market due to space-based research. Another area is in biofuel or food production, where plants grown in space are a lot more resilient. As you can see, there's a vast array of work being done now in the space sector, but we're hitting a bottleneck. Currently, the only platform that you can do this type of research is the International Space Station. For scientists, it takes nearly 2 years for the time from they conceive their idea to actually getting their samples back here on Earth. And not only that, it's very costly, costing nearly $1 million per experiment. And if you actually happen not to be from one of the 5 member space agencies, you're not allowed to go at all. We want to change all that. Introducing the Biocube. What you see here is a prototype of a fully functioning satellite that is packaged into this 10-centimeter cube. Now, these satellites aren't new to the industry. In fact, over 300 of them have been launched since 2002. But we're doing something different. What we put inside helps to drive the science and conduct the experiment and does an analysis. That analysis is then sent back to the researchers here on the ground. Now, as a scientist, you merely go onto our website, choose the experiment that's right for you, choose your launch date, and then send your samples to us. We do everything else, from packaging your sample into our Biocube, then doing the safety reviews, launching it, operating it, and collecting that data. That data is then transmitted right back to the researcher. We make it as simple as possible for that researcher to do this type of work. In fact, they don't even need to know what happens inside that black box. Now, to do what we're trying to execute here, we've partnered with a number of service providers. Listed here are ones we've already spoken to or have written agreements to do these things. Now, with that partnership, we can now turn around one of these satellites in 6 months. Not only that, with our off-the-shelf components and hardware, we can make these costs much, much cheaper, $100,000 per experiment now. In addition, as a commercial enterprise, we now make space accessible for the first time ever to any scientist around the world. Now, the current market is really driven by NASA. $330 million are spent annually on space station research. But as the space station's coming to an end, there are 360 experiments on board that need a new home. We think with our capabilities, we can capture 1/6 of that. We already have scientists coming to us and writing us letters of intent to use the platform as we develop it. But with that, we can grow into a much bigger industry where there's the biotech and pharmaceutical industry, where they spent $13 billion last year alone on the early drug discovery work. Now, already major pharmaceutical companies like Amgen and Merck are already doing some and have done a number of studies in this area. But with our versatile hardware, we can also address the material science research market, food and biofuels, as well as these 40 other space agencies that can't even access the space station now. Let's take a look at our costs and make sure that we can even return a profit. So our small CubeSats with a combination package of services, hardware, and launch costs us $200,000. We sell at $300,000. But because we can stuff in essentially 3 different experiments, we can spread that cost and lower it per researcher. Now, the modularity of our small Biocubes, we can stack 2 together. Once you stack 2 together, it's a little bit additional cost for us, but the extra return and capability drives those profit margins. Now, we're not the only ones in this space. We also have competition in areas such as ground studies. These are not always the most accurate and also hard to validate. There are also other space labs, like the Chinese and the Russian ones, but we're not sure if they're actually publicly available. More promising are orbital vehicles like SpaceX, but really none of them have the advantages that come with the small satellite market, whether it's lower cost, lower safety requirements, and above all, high quality of science. Now, we have put together a pretty exceptional team. Luis, my co-founder, and I have led and managed a number of engineering projects throughout our careers. We've garnered over $350,000 for our own research, showing that we can indeed write a lot of proposals and grants. In addition, we brought in our biologist, who's a postdoc now at BioFrontiers at CU, as well as our business analysts. To help with our backgrounds, we also have an incredible advisory team, 3 of whom have been very supportive of us. Dr. Louis Stodek, who is the director of Bioserve Space Technologies, has launched over 100 experiments into space. Dr. Pete Warden, director of NASA Ames, was so excited about our idea, he invited us last fall to present in front of his executive board. And Mr. Uli Kubler, who is the director of business innovations at Airbus, has connected us actively with his life sciences team. Now, our plan is driven because of the number of scientists that have approached us already, as well as the interest from NASA and the European Space Agency, as well as the Brazilian Space Agency. We've pushed our timeline to be much more aggressive and are aiming for our first launch by the end of 2016. That means we need to develop our prototype by the end of the summer. Right now, we're writing a number of small business grants, or SBIRs, to really capture that and also push our engineering and science teams forward. Really, we are at the edge of a new frontier where biology meets aerospace. What we will discover here will be incredible, breathtaking, and absolutely revolutionary. Are you ready for it? We are. We're the Space Research Company. Let's create the future.